مرحبا يا شباب. Welcome to part 7 of this tutorial series. As you can see in the last video, we just added the Retrofit client, the implementation for the Retrofit client to interact with our task API. And now it's time for the actual business logic. So let's create a new package. We're creating the repository. So create repository. Great, great. It rhymes. And this will be our task repository. And this will be an interface. And to give you an advice, every time you you will implement actual business logic. Now we'll just do all the CRUD operations. And now we have to think before we implement things. What we need is to get all the tasks, and depending on the status for all tasks, really all tasks or open or just the closed tasks, then we have another method for just getting a specific task with the ID. We will have another case where we just want to create a task. Another case will be when we want to delete a task. And the last case we have to update the task. And it makes really sense to think first about these things, what you need, and to apply some solid principles. You should always aim to have interfaces for business logic, to have abstraction, so you have a high-level overview what is happening in your code base. And so let's start creating the contracts, get tasks. As a the status will be a type of string, but since we are going to use only closed or open, if we want to have all tasks, we will pass nothing. So that's why it's nullable. So that's why the question mark. Status can be nullable. And of course, this will give us the view state. And here the view state will be a list of our responses, task fetch response. Okay, great. We have another suspend function because we are using coroutines. Get task by ID. Here we need an ID. This is necessary. That's why it's not nullable. And of course, we have again a view state. And this will be a single response object. So that's just task fetch response. Okay, next will be creating a task, create task. And here we need an object. So that's why our argument will be of create request, task create request. And of course, this gives us as well a view state of type fetch response. So we know that our operation was successful or not. Then let's do the delete stuff. Can delete task. I mean, the name already can delete is already, not sure if we can. So that's why it will return a Boolean value, but first we need it as an argument a string. And here the view state will be different. The view state will be a response, a retrofit response of type Boolean. Okay, and last but not least, our last method, update task. Here we need again a string and as the body update request, task update request. And this will again give us a view state of task fetch response if it was successful, the operation or not. So that's it for the actual interface. Now we have, the nice thing here is we have now listed our actual logic rule apply in an abstract way. So everyone, without seeing the actual implementation, knows what is going on with the repository. So now option enter, implement interface. And yeah, that's good. And okay. Okay. Now, let's do some things first. I mean, even though we didn't set it up yet, the dagger hilt for dependency injection, we can still use it. We cannot run the app right now, but we will now start using it. So in order to use dagger hilt, we need add inject class add inject constructor. Okay, let's get imported. Let's import it. As you can see, it needs to get imported. Okay, JavaX inject and the constructor, and here we can pass a field. Should be private to encapsulate it. And here we'll say I would just call it API service. And this will be of type task API. And remember, we don't want, it's always a good practice to just pass the interface to be more flexible instead of the actual implementation. And so that the right class gets injected here with the actual implementation. This will be done with Dagger. And we also need to inherit from, this is our interface. The task repository is our interface, but we have an abstract class. So that's why we will use base repository in here and do like this to have some logic predefined for us. And yeah, that looks pretty much good, I would say. What we else need is some constants. Companion object is needed right now. Okay, this will be, I think this class will be used somewhere else as well. So let's keep it public, or just make it, can we do it private? Yes, private. HTTP exception. So what I'm doing here, I'm just defining an HTTP exception when it occurs. Exception. HTTP exception. Okay, it looks good. I mean, I can. Okay, looks good, I would say. Now another constant. This is for delete, when we delete stuff. We're checking now if it's successful. Success, no content. This is the 204 HTTP code. Unfortunately, Retrofit doesn't provide any constants for this. That's why I'm creating it right now. If it does or so, just let me know in the comment section. Okay. Okay. Great. And so let's start with the implementation, I would say. Okay. But before we start with the implementation, we need something else as well. We need some kind of a wrapper method for all the things, because the CRUD operations are pretty much the same. That's why I will create first a new suspend function, a generic one, as you can see here, uptype, so we can use it for everything, any, let's call it perform save API call. Okay, now let's see what we need. We will pass a higher order function, just a method we can pass in here. Let's say API call is of type. I mean, to give it a better name, I would just say call API, call API. Let's say suspend. Let's do this one and say, okay, just make it generic. And what should it return? Of course, it needs to return a view state, a generic one. So type T, curly braces. Now we are good to go. Good to go. Okay. Okay. Let's do return, and we are trying some try catch. So you can also add here a catch block, and to be precise, yeah, let's start. Okay. Remember, we have a handle success method, which comes from our base repository. Oh, now it comes in handy. Okay, we need the call API dot invoke. Okay, now this function will handle this stuff for success. Okay, and otherwise, if we got an error of type HTTP exception, we can log it. First, we want to log it, of course. That's why we're using Timber for exceptions now. And then we say quotes, $, and we use our HTTP exception constant, which is here, as you can see, HTTP exception. And then we say just, I would say, let's log it with. Now let's take the error message and say get message. Okay, but we still need one more. Oh, God damn it! What did I do? Okay, now we need handle exception, and here we need the error code. Nice, the ID is pretty smart, I would say. The handle exception comes as well as from our base repository. And yes. As you can see, this will be done here. Get error message code, fused error will be set. It's great. And one more catch block we need if it's something else. If the error is a generic exception, just say one more block. Again, timber.e. This will be an unknown exception, I would say. You can also create a constant for this. Unknown exception. Let's take this one, unknown exception. And let's say, still we need error message in here as well. And here we just can set the view state to error. Okay, now we have our base method, our wrapper method, I would call it that way, set up, and now we can start using it. So basically what we can do is now say remove all of this, say equals perform save API call. Yeah, perform save API call. God damn it. Okay, perform save API call, and now we can say, well, task status equals task status dot, there it is, values dot find if the iteration name is equals to status, and this will be nullable, so that's why we need to string. Okay, I hope this was right, not sure yet. Okay, and now we can, basically it must be right, but say, where's our API service, get tasks, task status. Something is, I'm sorry, I'm so sorry, just made a mistake here in get tasks in the task API here. This should be nullable. Yes, this should be nullable. Now task repository, now this works. Okay, great. Now we can just continue with the implementation in here. Like do again perform save API call. So it's just API service dot get task by ID, pass the ID, and you should be good to go. Nice. And yes, let's continue with create tasks. Let's perform save API call, API service, create task, give it the argument in here. Okay, that's good. Just continue. Yeah, just continue with can delete. This is a little bit different. Can delete is a little bit different. Yes. First of all, we need a response. API service can delete. Give it the ID. Okay. Now we have the response, and now we check if response dot code is not equal to success no content, then we say throw HTTP exception, and we say response. Let's put the response in here, and yeah, otherwise it's just response. Yeah, sorry, I forget. Let's just this should be also wrapped in perform suspend call. So sorry. Perform save API call, and let's do this. So basically what we are doing, we just check if it can be deleted, then we get the response, and this response is, yeah, as you can see, response boolean, and then we can check, I mean, to help you a little bit, make it a little bit more readable. We just say Boolean in here. Now we have the code to check if it's 204, not 204, just throw an HTTP exception and give it a response. Okay, okay. Next thing what we are going to do is to implement updating a task. So again, perform save API call, and let's say API service update task. We need the ID, we need the update request. Yeah, that should be it. We are covered right now with the task repository implementation. Unfortunately the video gets quite long right now, and I will stop it in here. If you have some questions, write me a comment in the comment section down below, like and subscribe, and see you in the next tutorial. Ila liqa ya shabab.